As promised, I am uploading some of the discussion from today's class, which started out with the question, what is a bond? And in the student groups, the groups came up with the following representations. Bonds are the things that connect the atoms together in a molecule. So a bond connects the atoms. Okay, so that's pretty straightforward. More specifically, you said that it was composed of valence electrons, so the bond is made up of valence electrons from those atoms that they're shared. The electrons in the bond, and these are covalent molecules, so these are shared electrons. Specifically, one electron from each atom. We've only dealt with 2 electron bonds so far, so that makes a lot of sense. And that this is allowed by overlap of the atomic orbitals on those individual atoms. So overlap of atomic orbitals allows for sharing of electrons between those atoms, and those electrons are specifically the valence electrons of the atoms. You also said that this increased the electron density between the atoms. And that is a pretty good characterization of a bond. The bond results in, a bond is between the atoms, it's holding the atoms together, and that is of course an increase, can be seen as an increase in electron density, and most importantly, lower energy. And the groups decided that this resulted in a lower energy for the electrons in the bond compared to those same electrons in the free atoms. So with this characterization of the bond, I think this is a good list. We can go on to show this, represent this with an example that's used in almost every textbook, and that is the bonding of 2 hydrogen atoms to form H2 molecule, an H2 molecule. So here we have H1 with its 1s orbital, its valence orbital, represented by the gray shading in that sphere. And then hydrogen number 2, its soon-to-be partner, with its 1s orbital, and presumably each one of these has 1 electron, so 1 electron per atom. They're going to start at a distance r and a certain energy shown by that first dot at A. So we have distance r between the nuclei. Okay, so they're far apart. At this point they don't really feel each other's presence, but we're going to start moving them together and see how the energy overall changes for this system. So we move them to a point R, closer together, B, and what we see is that the orbitals are starting to overlap. The nuclei are closer together, right? And at this point, the electrons in those orbitals not only feel the positive charge from their own nucleus, from the atom that they rode in with, but also from the atom that they're now sort of joining with. So the electrons feel the nuclear pull from 2 nuclei in between these two atoms. If we move them a little closer together to point C, like this, now we see that the energy has dropped even more stability, lower energy. The nuclei are closer, and we see the darker gray between the nuclei representing the formation of the bond, and things are getting more stable. And the electrons are feeling the pull of those 2 nuclei even stronger. At some point, we reach the optimum distance between the atoms. And in the case of hydrogen, this is at a distance 74 picometers, which is in fact the a bond length, what we call the bond length for hydrogen. And there was a distance between those 2 nuclei is now 74 picometers. You can see the energy is at its lowest point so far, and that's going to be the minimum energy, right, for this formation of this bond. And we see that we have a greater electron density between the nuclei than we have so far, represented by the darker gray shading. Okay, so the probability of the electrons is very high between those 2, and that represents the bond, as you discussed in your own criteria in the previous page. Okay, and this is our H2 molecule. Bond length of 74 picometers. Now if we move them closer together, closer than 74 picometers, closer than their ideal bond length, what happens is they start to feel some repulsion, right? Those two nuclei are positively charged, and they would like to keep a certain amount of separation between each other. Otherwise, they start to feel a charge repulsion between the nuclei. So if we bring them in closer, so that R is less than 74 picometers, what happens is the energy shoots up. There's too much repulsion between the nuclei. However, we do have an optimum distance, 74 picometers. Go back, just look at that once more, for this hydrogen atom, and that is the bond length. And this is the formation of a bond.